Life as we know it is incredibly complex and diverse, so you can't help but wonder, how did we get here? Where did we come from? Where did everything come from? Everything evolves from something else. The Paleozoic era is often overlooked, as it is seen as a boring era of time. However, it is one of the most chaotic and instrumental building blocks that lead to life as we know it. With multiple horrifying mass extinctions, as well as explosions in both fauna and flora evolution, the Paleozoic era is far from boring. To see where it all started, we have to take a deep dive underwater. Before the Paleozoic era, during the Precambrian, life was extremely simple. Life was mainly immobile, figuratively and literally. This all changed, however, with the Cambrian explosion beginning approximately 541 million years ago. Due to an explosion of phytoplankton in the oceans, causing a rise in oxygen levels in the oceans, as well as erosion, allowed for life to evolve at a rapid pace. One notable trait that first evolved during this period was eyes, a trait still kept by most fauna to this day. This period saw the first predators, such as Anomalocaris, an earlier ancestor to arthropods, which resembled a large shrimp-like creature. Some creatures developed hard exoskeletons while others developed the ability to swim, while some anemones, such as jellyfish, stayed generally the same. The Cambrian period came to an end with a mass extinction, which is still unclear. However, it is theorized that a drop in oxygen may have been the cause. The Ordovician period's beginning was marked by another explosion of life, the Great Ordovician Biodiversification Event, which began around 485 million years ago. It is believed that major geographic changes due to tectonic activity, as well as another rise in oxygen, may have been the main factors. With the change in sea level, as well as new land, a playground for evolution to take place was created. During this period, the first fish would have been seen, as well as large arthropods. It also saw the first land plants, which resembled moss and could only grow on rock. These early land plants, although extraordinary, caused the downfall of this period, as well as 86% of all aquatic life. Because these plants took in massive amounts of carbon dioxide, warmth was sucked from the atmosphere, causing a devastating ice age. During the Silurian period, life slowly and gradually returned as the Earth's temperature began to rise again. This period saw the first vascular plants, as well as the first fungi on land. Fungi were instrumental in the further evolution of plants, as fungi had begun to break down material into soil, which, although unknown at the time, made all the difference later. Underwater, fish had begun to develop jaws. This gave certain fish a fin up, as jaws allowed for a more broad diet, including organisms that weren't as easy to eat beforehand. The Silurian came to a less intense end than the previous periods, with a couple of minor extinction events most likely caused by a drop in sea level. The Devonian period, which began approximately 419 million years ago, saw the evolution of many organisms more familiar to present-day fauna and flora. This period saw the first sharks, as well as large-jawed fish known as placoderms, which were predominant rulers of the aquatic world. On land, however, it was the arthropods who ruled. During this period, the first insects evolved, as well as the first trees, creating the perfect habitat for insects and the first real terrestrial ecosystems. The first reptiles also emerged at this time, evolving from shallow water fish. The period came to an end with roughly 2 mass extinctions, also known as the Late Devonian extinctions. Caused by yet another drop in oxygen levels, this mass extinction wiped out all placoderms, among other organisms. And as we can tell today, the sharks survived. The Carboniferous period, most likely being the most famous of all periods during the Paleozoic era, began with yet another rise in oxygen levels, although this time the rise was particularly high. Combined with a warm climate, thick, dense forests began to grow all over the globe. This increase in oxygen also caused the insects, or arthropods, to grow extremely large. An example of this was an arthropod called the Meganuera, which resembled a large dragonfly. Its wingspan would have been roughly 30 centimeters, and aside from the arthropods, early reptiles began laying eggs on land. This allowed for full terrestrial adaptation, which turned out to be super beneficial, as during this time supercontinent Pangaea had begun to form, taking away moisture from many land masses. Had it not been for this seemingly insignificant adaptation, many terrestrial creatures, including humans, might have never come to be. Because of this new lack of moisture, a majority of the humid forest ecosystem disappeared in an event called the Carboniferous rainforest collapse. Eventually, vast deserts took the forest's place, marking the end of the Carboniferous period. The Permian was the last period of the Paleozoic era. With an increasingly harsh climate being created, life was forced to adapt. The early reptiles, who weren't actually necessarily reptiles, split into two groups, the actual reptiles and the synapsids or mammals. Due to an increasingly hot and dry climate, the two groups were both forced to adapt. Some species evolved to become carnivores. The Paleozoic era came to a horrifying end. The Permian-Triassic extinction event, most likely caused by climate change and volcanic activity, wiped out 96% of all marine life and 70% of all terrestrial life. But as seen during this era as well as others, life rebuilds itself. The Paleozoic era was a crucial point in Earth's history that brought about the organisms common to us today, an incredibly diverse range of fauna and flora. And imagine how different the world may have been if it had never occurred. No humans, no terrestrial life, no nature documentaries. Despite being constantly overlooked, the Paleozoic era was one of the most crucial time periods for life itself. The Ordovician period's beginning was marked by another explosion of life, the Great Ordovician biodiversity. The Ordovician period's beginning was marked by another explosion of life. The Great Ordovician biodiversification.